Engineering Technology, Department of Mechanical Engineering welcomes you to the video lecture for the course code ME8073 Unconventional Machining Process. It's me VP Praveen Jabba, Assistant Professor, Department of Mechanical Engineering. Today we will be discussing about the Magneto Rheological finishing. A electromagnet is placed below the moving balls, generating magnetic field in the areas of gap. The MR fluid is delivered to the moving wall just above the electromagnetic pole piece to form a polishing ribbon. The ribbon moves on the magnetic field. It acquires plastic Bingham's property. Magneto Rheological finishing, that is MRF process, is capable to fabricate an ultra-fine surface from the flat to three-dimensional profile structures using Magneto Rheological polishing fluid, that is MRPF. The MRPF is a smart fluid that can change from liquid to near solid state under the influence of magnetic field. Precision finishing of internal surface and complex geometry is always of concern, being labor intensive and difficult to control. Abrasive with small multiple cutting edges are generally employed to get desired surface finish categories and geometrical accuracy by removing underwater materials from the workpiece. The traditional finishing process such as grinding, lapping and honing works on this mechanism of finishing. But due to the development of new materials which are difficult to machine and complex geometrical shapes of engineering components, the available traditional finishing process are alone not capable of producing required surface finish and other characteristics of the product, and also processing of this required wide range equipment usage and more labor. Development in the finishing process in the last few decades have attributed to the relaxation of limitation of tool hardness requirement, that is in EDM, ECM, UCM, AGM, etc. Predefined relative motions of the cutting edges with respect to the workpiece surface is a major limitation in finishing complex geometries. To overcome this limitation, the multiple cutting edges in some loosely bonded from a directed to follow the intricate geometries to be finished, but due to the lack of control over the finishing forces, these possess the limitation for finishing complex geometry, and moreover sometimes these processes impart surface and subsurface damages. Many advanced finishing processes have been developed to tackle this issue. Magneto Rheological fluid assisted finishing process are one of the such kind of finishing process which has greater flexibility towards process control, and one can finish with close tolerance and without damaging surface topography. Many newly developed Magneto Rheological fluid assisted finishing process make use of the Magneto Rheological fluid MR to external control the finishing forces on a abrasive particle. Center for Optics Manufacturing, that is COM, Rochester, New York, has developed an automatic MR force process for finishing lenses. Since then, more number of polishing techniques are evolved using Magneto Rheological fluid. Few of them are MRF, MRJF, that is Magneto Rheological abrasive flow finishing, Magneto Rheological abrasive honing, and ball end Magneto Rheological finishing ball end MRF. Magneto Rheological abrasive flowing finishing. This process makes use of the Magneto Rheological fluid as a tool that acts as a flexible magneto-abrasive brush that provides finishing action. The relative motion between the finishing medium and the workpiece can be obtained either by rotating the workpiece, rotating the finishing medium, or both. Surface quality is the most crucial factor affecting the product lifespan and performance of any component. Most early technology displays accuracy in micrometer or sub-micrometer range, surface roughness in the nanometer range, and most non-surface defect in the production of optical, mechanical, and electronic parts. Such finishing methods incorporate a magnetic field to control the finishing forces using Magneto Rheological fluid as the polishing medium. Magneto Rheological fluid consists of ferromagnet and abrasive particles. This is a type of modern intelligent fluid. An optimum selection of Magneto Rheological fluid constituent and their volume concentration plays an essential role for the ultra-fine finishing of newly developed engineering products. Rheological characteristics of Magneto Rheological fluid can change rapidly and effortlessly with the support of an activated magnetic field. Traditional finishing methods are comparatively inferior in finishing complex free-form surface due to the lack of controlling finishing forces and limitation of polishing tool movement. over the complex free-form contour of the components. There are different types of process based on the Magneto Rheological fluid, including Magneto Rheological finishing, Magneto Rheological abrasive flow finishing, rotational Magneto Rheological abrasive flow finishing, and ball end Magneto Rheological finishing. In this process, the flowing semi-solid abrasive laden putty removes a small quantity of material from the workpiece surface to be finished. During AF process, the rubbing and flowing action of abrasive gain on the workpiece material is the mechanism of material removal process. And this is the diagram of the MRAFF. Thank you.